Let's look at fraction, decimal, and percentage, the relationship between them. Now, let's say you have a half. You may know already that a half as a fraction is the same as 0.5 as a decimal, which is 50 as a percentage. Alright? Now, the 0.5 is mean the same as 0.5 over 1. Because 0.5 is from the decimal system, and it means the same as 5/10. Okay? Here, the 50 is percent. So, what this means is 50 per, mean divide, out of, cent is out of 100. So, it's 50 per cent, 50 per 100. Cent, the word cent means 100. So, you have a batsman hits 100 runs, they say he makes a century. Someone lives to be 100 years, you say he or she is a centenarian. 100 cents make a dollar. So cent means 100. Alright? Now, what we want to do, some of the things we want to do is convert. We want to convert decimal to fraction. We want to convert fraction to decimal. So let's look at some of that. Alright. Now, let's convert 0.5 means 0.5 over 1. But originally, you would not see 0.5 over 1. We convert 0.5 to a fraction. If you convert 0.5 to a fraction, you first of all write it as 0.5 divided by 1. Then you don't want any more points, no more points. You want whole number over whole number. You want integer over integer. You must multiply the 0.5 by a number to make it a whole number. Well, you could very well multiply by 2. 0.5 by 2 is actually 1. And if you multiply up here by 2, you must multiply down here by 2 as well. But let's not do that. This is 0.5 over 1. Let's say, and this is a standard rule which applies in every case like this. You multiply it by 10. Up here you will have 5. It's like moving the point one place to the right. It's like moving the number one place to the left and making the point remain in place. But 0.5 by 10 is actually 5. But we must compensate by multiplying the 1 by 10 too, so it's 5 over 10. So 5 into 5 is 1 time, 5 into 10 is 2 times, so you have a half. As I was saying before, if you come up with this, multiply this by 2, multiply the 0.5 by 2 and this by 2, you're going to get 1 over 2. Alright? But what happened is that this rule of multiplying by 10, it applies generally. Suppose it was 0.05 that you should convert to a fraction. What would you do? What would you multiply this by to get a whole number? Right, you can't multiply it by 10, because when you multiply this by 10, up top here you're going to get 0.5. So it can't be by 10. You need to have whole number. Alright? So let's backtrack. You write the 0.05 over 1. Multiply this by what? By 100. You multiply 0.05 by 100. What you get is 5. Alright? And then you must multiply the 1 by 100 and you get 100. Then your fraction is 5 into 5 is 1 time 5 into 10, 2. In other words, 5 up here. What is 10? It's 5 by 20. So 5 cancel. This is like 5 by 1 over 5 by 20. When you cancel down the 5, you get 1 over 20. So the answer gives you 1/20th. So 0.05 is the same as 1 over 20. Now, that's a case of converting a decimal to a fraction. Let's look at another example. We're going to convert another decimal to a fraction and see what happens. Let's convert. Right. Let us convert 0.25 to a fraction. Remember, any number you write, it really means the number over 1. So I'll take advantage of that and put this over 1. What do you multiply the 0.25 up here by to get a whole number? You can multiply it by 100. So up top, what you have is going to be 25 times 0.25 times 100 gives you 25. Down here you multiply by 100 too. You notice 100 over 100 is 1. So it's like multiplying the 0.25 by 1. What you get is also 0.25, but it looks different, but it's the same size. So this over 100, and you can cancel down. You can say 25 into 100 goes 4 times and get a quarter. Or you can cancel down with 5. Whichever way you choose. You could say 25 is actually 5 by 5. 100 is actually 5 by what? 20. So 5 cancel 5. I end up with 5/20th. But guess what? 5 is 5 by 1 and 20 is 5 by 4. 5 cancels 5 again and I have a quarter. Alright? So 0.25 is the same as a quarter. 0.25 as a decimal is the same as a quarter as a fraction. So let me make a note of that. I have the 0.25. I converted 0.25 to fraction and I get a quarter. Now what I want to do is convert the quarter to a decimal. Now when you're going to convert a quarter to a decimal, use long division. Have a long division sign, you say 4 into 1. So you have 4 into 1. 4 into 1. 1 is smaller, so you can't. It's going to be a 0 point something. 0.4 is 0. 1 minus 0 is 1. Now, if you multiply this by 10, add a 0 to get the next place. 4 into 10. There are how many 4s in 10? There are 2. 2 by 4 is 8. 10 minus 8 is 2. Add a 0 to the 2. 4 into 20 goes 5 times. 5 4s, 20. 20 minus 20 is 0. Doesn't make sense to continue. Because if you add a 0 to this and say 0 into 4 into 0 is 0, 0 4 0, and you keep repeating yourself. So you end up at 0.25. All right, that's a long division way of converting a fraction to a decimal. You use long division. All right, now just before I finish off, each time I said to add a 0 here. Remember, when you are converting and you say 0.25, what you really have here is 0 tens plus 0 ones. I mean, it's 0 1 plus 2 tenths plus 5 hundredths. And if there was another digit, it would be something thousandths and so on. So if you add a 0 to 10, you get 0 1 0 0. If you add a 0 here, you get 1 0 0. So you're really dividing by 10 each time. 2 tenths. The next digit is 1/10 of this digit. So 1/10 of 1/10 of a tenth is a hundredth. 1/10 of a hundredth is a thousandth. So you keep adding a new 0. So even though I said add a 0, what I'm really saying is divide by 10. It looks as if I'm multiplying by 10, because when you go under the fraction and multiply the denominator by 10, what you're really doing is dividing by 10, because you're multiplying by 1/10, which is the same as dividing by 10. So when I'm doing the long division and say add a 0, that's what is happening. I'm really dividing by 10. I'm putting in the 0. Alright? But you will remember your long division algorithm. So this is how you convert your fraction to a decimal. One more example before we finish. We're not going to do percentage in this particular lesson, but we'll put it off for another time. Suppose, for example, you have 5/11. You want to find out what decimal this is. I'm going to do my long division. 11 into 5. 11 into 5 goes, I can't, it's smaller, so I put 0 point. 0 times 11 is 0. 5 minus 0 is 5. Add a 0, which means I'm really dividing by 10. This is all denominator. This is denominator, dividing by 10. 11 into 50. How many 11s are there in 50? 11 2 is 22, 11 3 is 36, 11 4 is 44. There are 4 11s in 50. If I multiply the 4 by 11, I get 44. 50 minus 44 is what? 6. Alright, I must divide again. Divide it by 1/10 of what I had before. So I divide by 10, and that additional 0 I put here, so I add a 0. 11 into 60 is what? 11 5 55, 11 6 66. So there are 5 11s in 60. So I put my 5 here. 5 11, 5 times 11 is 55. Subtract. What do I get? 5. What I had here, I divide by 10 again, and the extra, that 0 that is added on, I put it on 50. 11 into 50. How many 11s are in 50? There are 4. 4 times 11, 44. 44. Subtract, I get 6. Divide by 10 again, so I add a 0. But guess what? I realize something is happening. I'm repeating myself over and over. And I realize that this will become 4 5 4 5 4 5 4 5, on and on and on like that. Now, the pattern of this fraction keeps repeating itself. There's a repeating pattern here. This is called a recurring decimal. A recurring decimal. The pattern keeps occurring, reoccurring over and over again. So it's a recurring decimal. Alright? Finally, what I want to do is write down the answer. I want to write down the answer. 5/11 is equal to. One way that it can be done is to put 0.45 and 2 dots up here to show that the 45 keeps repeating. I've seen cases also where they put a line up here to show that the 45 keeps repeating. Alright? So, that's one way of writing it. Now the thing is, right, let me erase this for now. We know it goes on and on, 45, 45, 45. There's the issue of writing down the answer to a certain accuracy. If I want, we're going to look at this in more detail later on, but 0.454545, if I want to write this and stop at the 4, to one place after the point at 0.4. But the thing is, 5 follows it. If the number after where you're going to stop is 5 or more, you must add 1 to the number you're going to stop. So I must add 1 to this 4 and make it 5. If I was going to write it to 2 decimal places, 2 digits to the right of the point, I would have 0.45. I wouldn't have to worry about changing the 5 because the number that follows it is really 4, which is less than 5. Once it's less than 5, you keep this number. Alright? As for the reasoning behind it and more in example, that will come at a later lesson when we look more closely at writing down decimals in number of decimal places, writing it in scientific notation, and to a certain number of significant figures, but that's for another lesson. Alright, so we're going to take a break here and we come back later on with putting percentage into it all.